So in this question, we're given the graph of an ellipse, and we want to match this graph to the equation. And we're given some different equations to choose from. And in order to figure out which equation matches, we need to really understand a couple different things about the ellipse. So I've taken a screenshot from our notes that we're going to take a glance at. And these are the equations of some ellipses. And I've got them oriented in two different ways, a horizontal orientation and a vertical orientation. So this first equation has a horizontal orientation and this second one has a vertical orientation. So let's compare the two equations just so we can see what are similar to each other and what are different. So I'm going to highlight what is the same in yellow. They both have x minus h squared. They both have y minus k squared. They both equal 1. However, what's different is that we have a squared underneath the x on the horizontal orientation and b squared underneath the x on the vertical orientation, and then vice versa over here. So this is going to tell us what the orientation is if we understand how these are set up. Now, in order for us to understand it, we have to know what A, B, and C stand for within the ellipse. So in the ellipse, you're going to have a center, and that center is going to be that HK. And with the center, we have foci, which occur horizontally on the horizontal orientation and occur vertically on the vertical orientation. So in red we have the foci. And then we also have vertices, and the vertices occur horizontally on the horizontal orientation and vertically along the vertical orientation. And when I say it's horizontal oriented, it means it's longer horizontally. Vertically oriented is longer vertically. So those are some features that we care about. Now, the distance between the center and the focus is the value of C. And the distance between the center and the vertex is A. So you can see here that when you're vertically oriented, your A is along the longer part. And that's how we're going to tell what A is. A is longest. So because A is the distance between the center and the vertex, it's going to be the longest. So A is the longest. So when I look at my picture over here, I can see that this is vertically oriented, and because it's vertically oriented, the longer one is going to be underneath the Y. So I can go ahead and eliminate this one because Y has a shorter one, and eliminate this one because Y is shorter. And then from here, it's really easy to eliminate this one because it has a minus instead of a plus. Now, if we want to get into details, you can see here that the center is at 0, 0. And then if we go to the vertices here, those are at -9 and 9. So you can see that A is equal to 9, and that's why 81 is used in the equation. I haven't mentioned B yet. Now B is the distance between the center and the shorter side, and that's a distance of 1, and that's why we have a 1 squared underneath the x squared there. So in this example, we get x squared plus y squared over 81 equals 1 as the equation of the ellipse. On this example, we want to find the equation for the ellipse. We're going to graph the equation with center at 0, 0, a focus at 0, -12, and a vertex at 0, -13. Now over here on the left, I wrote out the two orientations for our ellipse. We have a horizontal orientation or a vertical orientation. So what I'm going to do is I'm going to start to graph these details to help me understand which equation I should start from. So just as a reminder, the horizontal orientation will have an ellipse that's longer horizontally, and the vertical orientation will be longer vertically. Okay, so when I'm putting this information down, it's going to help me to figure out that orientation. So our center is at 0, 0. We have a focus at 0, -12. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That's our focus. And then we have a vertex at 0, -13. So maybe you think that that's not enough information, but I also know that my horizontal orientation will have the center and the foci to the left and right, and the vertices to the left and to the right. And with my vertical orientation, the center will be there, above and below will be where the foci are, above and below will be where the vertices are. So based on the placement of these points, since they're lining up with each other vertically, I know that this equation is going to match the one with the vertical orientation. So I'm going to use x minus h squared over b squared plus y minus k squared over a squared equals 1. Now, we need to fill in these pieces, h, k, b, and a, in order to write the equation in detail. So we have to know what those things stand for. So the center is our hk, and we were given a center of 0, 0, so we know that h is 0 and k is 0. We also need to know what a and b stand for. A is going to be the distance between the center and a vertex. B, that's the distance between the center on the shorter side, so I call it the minor vertex. And C is the distance between the center and the focus. So we can see here that our A is from the center to this vertex here, and that is a distance of 13. So I know that A is 13. And C is the distance between the center and the focus, so that's going to be 12. So C is 12. Now, we didn't get any information about how wide this this ellipse is, so we're going to have to use this equation here to figure out what B is, and that's why it's there. If we know two of them, we can find the third. So B squared plus C squared equals A squared. B squared plus 12 squared equals 13 squared. I'm going to subtract 12 squared and get B squared equals 13 squared, that's 169, minus 12 squared, that's 144. So B squared is equal to 25, and that means that B is equal to 5. So I can write the equation, and I can also draw the graph now because I have all the details. So filling in the center of 0, 0, filling in a B of 5 and an A of 13 would give me x minus 0 squared over 5 squared plus y minus 0 squared over 13 squared equals 1. That's x squared over 25 plus y squared over 169 equals 1. And I can also graph that parabola. I know because of the symmetry, I think I called it a parabola again. This is an ellipse. I can, because of the symmetry, go up 13 and in both directions around the center 5, and I'll be able to draw my ellipse using those vertices. So let me zoom out so we can see all of our work. So for this example, we want to solve the inequality algebraically. And this inequality is x cubed minus x squared minus 12x is greater than 0. And because this inequality is a polynomial inequality, we have a strategy that we go through that's a little bit different from solving a linear inequality. So first off, we want to make sure that we have all the terms on one side and 0 on the other side of the inequality. And that sets up our process for being able to pay attention to whether our expression is positive or negative. So this says greater than 0 is positive, equal to 0, and negative would be what we're not looking for. So positive is what we're looking for, negative and 0 are not. So we start with the boundary. The boundary points are where this inequality is equal to 0, where this expression equals 0. So we're going to solve that equation. X cubed minus x squared minus 12x equals 0. So I can solve this by factoring. I'll factor out an x. That would leave me with x squared minus x minus 12. I can factor some more. Get x times x is x squared. 4 times 3 is 12. If I put a negative on the 4 and a positive on the 3, that will give me the right number in the middle. And then I can set each factor equal to 0. So x equals 0 gives me one value of x equals 0. I add 4 to both sides and get x equals 4. On the equation x plus 3 equals 0, I would subtract 3 and get x equals negative 3. So you can think of these as boundary points, or if you're thinking of it graphically, these would be x-intercepts. And you're going to take your number line and you're going to put those numbers on your number line in order from smallest to largest. So that's negative 3, 0, and 4. I'm going to draw these with open circles because remember, in our inequality, we are only interested in the points that are greater than 0. So we're not interested in these boundary points because they equal 0. So then we go inside each one of these intervals and we choose test points. And we're going to test these intervals to see whether they are greater than 0 or less than 0. So I want to pick a number that's less than negative 3, like negative 4. Something in between negative 3 and 0, like negative 2. Something in between 0 and 4, like 1. And something greater than 4, like 5. And we're going to test these in our expression. So we take our test points, and we're going to plug them into our expression x cubed minus x squared minus 12x. And all we really care about is whether it comes out positive or negative. So let's test each one of these test points. Negative 4, that's negative 4 cubed minus negative 4 squared minus 12 times negative 4. Negative 4 cubed, that's going to be a negative 64, I believe. Let me just double check. Yep. And this would be a minus 16. So I carried that minus down, and negative 4 squared is a positive 16. And 12 times 4 is 48, and that's a plus 48. And so I can see that this is going to come out to be negative. So because that came out to be negative, that means that all of the y values in that interval are negative. Let's try the next test point of negative 2. We have negative 2 cubed minus negative 2 squared minus 12 times negative 2. That's a negative 8 minus 4 plus 24. Negative 8 minus 4 plus 24 is going to be a positive, and so I know that this interval comes out positive. Let's try the next test point, which is 1. 1 cubed minus 1 squared minus 12 times 1. It's 1 minus 1 minus 12, and I can see that that comes out to be negative. So that means that that interval is negative. So final test point is 5. We have 5 cubed minus 5 squared minus 12 times 5. So 5 cubed is 125 minus 5 squared minus 12 times 5. So 125 minus 25, that's 100 minus 60. That's going to be a positive. So we get positive for that last interval. So once again, remember, our goal was to have positive values. So we've identified the intervals that give us positive values, and those will be the solutions to the inequality. So from -3 to 0, and I'm going to put parentheses on those ends because they produce values that equal 0. And then also from 4 on forever to infinity, 4 to infinity, and we have our solution set. All the numbers from -3 to 0, excluding the endpoints, and all the numbers from 4 to infinity, excluding the endpoints, will make this expression greater than 0.
Thank you for checking out my videos. Have a great day.